So this is just a FYI, just a quick little tutorial on a condensing unit. You have a condensing unit here. Condensing unit consists of a compressor, a condensing fan motor, a condensing coil. The cycle of refrigeration works as follows. Out of the pump, this is a vapor pump. This actually pumps the refrigerant out of our discharge line. This discharge line actually goes into the condensing coil. The condensing fan turns on, cycles the ambient air through the coil, and does what the coil is named after. It condenses the vapor into a liquid. So at this point, we're at high pressure, high temperature vapor. After it comes out of the condenser, it comes out on what's called the liquid line. This liquid line is labeled as such. It is it should be 100% liquid. We have a dryer that picks up any contaminants from the compressor or any contaminants provided by our service ports here from either service techs not cleaning their gauges out, or the dust or dirt that kind of goes onto these. That's why it's very important to have our caps on these. They'll collect dust, and that dust goes inside when you actually put your gauges on there. So this collects any molecules, it collects water, any condensation that might be in your service gauges. So this actually collects all the materials, shavings from the compressor, things of that nature. So this collects any more particles that kind of go through. It goes through here as a 100% liquid, like I stated. It goes towards the air handler. Air handler is consisted of an evaporator motor with an evaporator coil. Just like the name of the component, it will evaporate this liquid into a vapor back. But at that point, it will be at a low pressure, low temperature state. It comes back on what's called a suction line. This is actually being sucked back in. So this is the back side of the pump. There's the front side of the pump. Sucks in, pushes out, just like any type of water pump or anything of that nature. There's an inlet, there's an outlet. That's the inlet, that's the outlet. You could easily identify it as the thickness of the pipes. As the pipe is thick, it's considered the suction. Pipe is thin, is considered the discharge or liquid line. Discharge line will be coming directly out of the compressor, liquid line coming straight out of the condenser, going towards the evaporator. So again, just by reference, somebody says liquid, it'll be this one. Somebody says suction, it'll be this one. Our components that we have are safeties, which will be a low pressure switch and a high pressure switch. High pressure switch will be on the high side of the pipe, which is the skinny side, which is the liquid line or discharge. The low side would always be the suction line, which would be the thicker line. The way the safeties work, that is a normally closed, this is a normally open, no power. It's not connected into our refrigerant lines. That is normally closed. This will be open. There will be no continuity. The way this actually works, if the pressure actually gets high, that would open, causing the safety for the compressor, so it does not overheat or anything like that, damage the compressor itself, so it turns itself off. It will close back at the drop, because that is an automatic. Usually there's a little red button on top. If there's a red button on top, that is a manual reset. You click on that and you hear the click, that means that the unit tripped off on head pressure. This is a low pressure switch. This actually works in reverse. This is normally open, meaning that it's not connected into our pipe, that you will not have continuity. As long as there's pressure inside the system that's above whatever this is rated. Again, these are rated based on refrigerant, so you cannot combine a R22 with a 410A. There are two different types of pressures. You cannot do that. It have to be based on the refrigerant that you're working with. So this would be a normally open. Once we connect it into a pipe and there's pressure within the system, that switch will automatically close. It will open only if there's a leak in the system, no refrigerant charge. It will drop and this device will open up, causing the compressor to turn off. Again, we don't want this compressor to run without gas. So that is our safety there. A typical setup for a condenser unit will be a contactor. The contactor controls the primary voltage to our fan as well as to our compressor. You have capacitors right here. There's one for the fan. There's one for the compressor. Usually you have a dual, which will have 3 prongs, one for fan, one for compressor. But again, in this case, we have them separate. We've added features to this unit. This unit has what's called an ICM. ICM control is basically making this unit work under the cold conditions. Winter. This is an AC. It's not designed to work in the winter. But by putting an ACM, we actually control our fan based on the temperature of the liquid line or the temperature of the coil, the condensing coil. If the temperature is too cold, it would not run this at full blast, allowing our pressure to rise. And then as the temperature rises, it kicks in and goes into full blast, into 100%. We do have safeties as well. We have a time delay, which is just identified as 2 prongs. The time delay will delay on startup before a cycle is over. This is a lockout relay, which is identified by 3. This is I apologize. I'm sorry. It's not lockout. That is a lockout relay that's placed down there. You can't really see it. It's dark. There it is. That's our lockout relay. This actually is a low pressure bypass. A low pressure bypass actually allows the unit to run for a duration of time to build up pressure during the winter time. Really not suitable during the summer. It's not applicable during the summer. It's only for winter. Right now we have it at 0 because we want to troubleshoot the unit, and we don't want this to actually bypass the low pressure switch. That's what this does. This actually bypasses the low pressure switch. So we'll test the unit out. We're doing a troubleshoot. We'll be testing with ohms. Ohms is continuity, so we'll be checking continuity. So on our meter, we have this on the ohm position.